Good morning, dear students. Today we'll study the topic valency. Children, valency is the combining capacity of an element or of an atom. Combining capacity means with how many electrons this atom is going to combine with other atom. As you are watching, oxygen is combining with two hydrogen atoms. This to make compound H2O. So, how oxygen is combining with two hydrogen atoms? This all we are going to study in this topic as its answer is given by valency. Children, the outermost shell of an atom is called its valency shell. Valency shell means the outermost orbit of an atom. When all the shells of an atom are completely filled, then it is called stable. And in valency shell only the electrons are present which decide what will be the valency. For an atom to become stable, it should contain 2 or 8 electrons in its outermost orbit. And if electrons are not 2 or 8, then this atom tends to make it stable. It tries to make it stable, means it tries that anyhow 8 or 2 electrons must be in its valency shell. Valency shell means outermost shell. So it is its tendency. Either it will gain some electrons to make it 8 or 2 or it will lose. So this is only valency. How many electrons are lost or how many electrons are gained, known as valency. For an atom to become stable, it should contain 2 or 8 electrons in outermost orbit, and this is called octet rule. Octet means 8. Valency electrons are those which are found in outermost orbit. The electrons which are found in outermost orbits, they are called valence electrons or valency electrons. Okay. Now, you can see here valency electrons are 2 because 2 electrons are present in outermost orbit. Let's take example of sodium. Sodium atom, its atomic number is 11, means number of electrons 11. In its first shell, 2 electrons are there. In second shell, 8 electrons are there according to the rule, and 1 electron is remaining, that will be in third shell. Now, M shell. This 1 electron will be donated by it to make it 8, because when this 1 electron will go from here, then its shell will be completed. So its valency is 1 because it is losing 1 electron. Same way fluorine. Fluorine's atomic number is 9. First shell has 2 electrons. Second shell has 7 electrons. Now 7 electrons cannot be lost. So it will gain 1 electron to make octet. So its valency is also 1. Now it will come in your mind how these both fluorine and sodium has valency 1. Then what is difference here? Children, its difference I will tell you. Actually, sodium loses 1 electron of its outermost orbit. It means 1 electron is reduced in sodium atom, and you know that electrons and protons are equal. It means now protons have become more than electrons. So it has gained positive charge. इसका पॉजिटिव चार्ज बढ़ गया है क्योंकि प्रोटॉन्स का नंबर ज़्यादा हो गया है. सो इट्स वैलेंसी वी कैन अंडरस्टैंड एज +1. Now in fluorine's case, its outermost orbit had 7 electrons, so it has gained 1 electron from out. So its negative charge is more than positive charge, protons. Electrons are more than protons, so its valency can be represented by -1. Now, we can take another example, oxygen. Atomic number of oxygen is 8, means number of electrons are 8. First orbit has 2 electrons, second orbit will have 6 electrons. So, in this case, to make it octet, 2 electrons will be gained. It will gain 2 electrons to become stable. So, if it will gain 2 electrons, the number of electrons or negative charge will be more in case of oxygen than positive charge. So, what will be its valency? -2, because electrons are more and negative charge is more than positive charge. Now, same way we can take one more example, lithium. Atomic number of lithium is 3. That is number of electrons 3. In first orbit it has 2 electrons and in second orbit it has only 1 electron. Now, it cannot complete the octet rule. Which rule it will complete? Duplet rule. So this 1 electron which is in second orbit, it will be lost, and to become stable it will lose this electron and then it will be stable. If it has lost electron, means its positive charge is more, so its valency will be +1. Children, number of valency electrons is valency when the number of valency electron is less than 4 or equal to 4, and valency is 8 minus number of valency electrons when the number of valency electron is more than 4. For example, the sodium's valency is 1. Why? Number of valency electron is 1 less than 4. And the valency of chlorine is what? Number of valence electrons 7. 8 minus 7 equals to 1. Understood or not? So, now next topic we'll study here is isobar, isotopes and isotones. So children, you know that mass number is the number of protons plus number of neutrons. An element is written as shown in the picture by its symbol, and symbol has atomic number and mass number both. Mass number is the number of protons plus number of neutrons. Atomic number is the number of proton or number of electron. Atomic number of hydrogen is 1 because one proton is only present. Isotopes. Atoms of same elements having same number of protons but different number of neutrons, or same atomic number but different mass numbers are called isotopes. Carbon has 3 isotopes. Carbon 12, carbon 13, carbon 14, and hydrogen also has 3 isotopes. 1, 2, 3, protium, deuterium, tritium. Now this table shows, it will make things more clear. Carbon 12, carbon 13, carbon 14, 3 isotopes you are watching. Atomic number of carbon 12 is 6. Atomic number of carbon 13 is 6 and 14 also 6. Mass numbers 12, 13 and 14. Number of electrons present in carbon 12, 6. Number of electrons present in carbon 13, 6, and in carbon 14, 6. Number of protons will also be same as number of electrons, but number of neutrons will be different, 6, 7 and 8. So isotopes are the same element, atoms of same element, equal number of protons, equal number of electrons, different number of neutrons, different mass number and same atomic number. Now we have next topic, isobar. Atoms of different elements that have same number of nucleons or same mass number but different atomic number, they are called isobars. Now we can see here isobars examples: 18Ar40, 19K40, 20Ca40. You can see that their atomic numbers are different but their mass numbers are same. Atomic numbers are 18, 19, 20. Mass numbers are 40 of all. And number of electrons will be atomic number 18, 19, 20. Number of protons, atomic number 18, 19, 20. But number of neutrons will be mass number minus atomic number, that is 22 in argon's case. 40 minus 19 equals to 21 in potassium's case. 40 minus 20 equals to 20 in calcium's case. So these are the isobars. Isobars means their mass numbers, they are equal. They are different atoms which have same mass number but different atomic number. They are called isobars. So isobars are atoms of different elements. They have same mass number but their atomic number is different. Now isotones. Isotones are one of two or more atoms having equal number of neutrons but different atomic numbers, known as isotones. We can see the examples here. Carbon 6C14, nitrogen 7N15 and oxygen 8O16. In carbon's case, atomic number is 6, mass number is 14, electrons 6, protons 6, neutrons 8. 14 minus 6, 8. And in second case, nitrogen's case, atomic number 7, mass number 15, electrons 7, protons 7 and number of neutrons 8. 15 minus 7, 8. Same way in oxygen's case, neutrons 8. So you can see here neutrons in all cases are same. So they are isotones. The same number of neutrons, different elements, different atomic number and different mass numbers. So I hope you understood. Thank you everybody. Have a nice day.